Bismillahirrahmanirrahim. Let's continue, inshallah. Number 21. The table below. The table below shows the price of different quantities of standard size lemons. Lemons at Joe's fruit stand. So Joe's fruit stand has lemons. Okay. What is the least amount of money needed to purchase exactly 20 standard size lemons? You know, small lemons, medium lemons, large lemons. So assuming that they want the standard size lemons. See. So what is the least amount of money needed to purchase exactly 20 standard size lemons if the bags must be sold intact and there is no tax charged for lemons? So okay, so in other words, okay, watch it. So you want 20 lemons exactly, okay? If you get one lemon, it'll cost you 30 cents. Okay? But if you get a bag of 6, it costs you $1.20. Because 6 times this would be 180 if you get one at a time. And if you get a bag of 12, you save even more. You get $2.10. But you want 20, so it's in your best interest to get the bags, because the more bags form you get, the more money you save. So you want 20. So you want a bag of 12. That'll give you 12, and then you can get one bag of 6. Okay, one bag of 6, that's 18. So, and then you have to get 2 individually, right? So, okay, one bag of 12 is $2.10. And one bag of 6 is $1.20, and you have to get 2 of that, 60 cents over here. So that's let's say that's 90, and $3.90 in lemons. You can make lemon juice out of it. Nice lemons. Okay, so $3, and that's 90 cents. 22. The diameter D of a metal poles, okay, it's a metal pole, of good pole manufacturing produces must satisfy this inequality. D minus 3 is less or equal to this. What is the maximum diameter in centimeters such a metal pole can have? Well, the diameter must satisfy this inequality. Okay? And why? Because it's the way it is. What's the maximum diameter it can have? Well, add 3 to both sides, so you can solve for D. So D has to be less than or equal to 3.001. What's the maximum you can get? It has to be less than or equal to this. So the maximum is 3.001. Ta-da. Okay, this is labeled incorrectly. I believe that's 23. Which of the following is a factored form of the expression this? Okay, so you have to factor this out. Well, they can't help you. There's 2 ways of doing this. You just kind of factor it, or you kind of just FOIL these and see which one works, right? So you look at these generally, well, they all look very similar, so we might as well just factor them, okay? So look, all of the choices here are x and all 1, 5, so they have to be x and 5x over here, right? Now you want 2 numbers that multiply to give 6 over here, right? And they have to add or subtract to give 13. So, okay, well, it looks like they're going to be 3 and 2s, okay? So I could put 3 and 2 over here, right? Will that work? I don't know if that worked. I could have put 2 and 3 over there. If this didn't work, I would have to switch them around. Okay, so this will give you 15. Okay, remember the FOIL. These have to add up to 13. 15, and the outer is what? Is 2. Do they add or subtract to give 13? They do. Now, see, this works. 15 minus 2 is 13. So this works. The last thing you do is put the signs in. So this is a negative sign over here. That tells me that these signs are going to be different. And this sign tells me the bigger product is going to be negative. This is the bigger product. So that's going to be negative, and this is going to be positive. So it's going to be x minus 3 and 5x plus 2. That's choice A. Okay? And this is the next question, I believe. Okay. A bag contains 6 red marbles, Why is somebody carrying out the bag? Marbles, don't know, but that's the way it is. A bag contains 6 red marbles, 5 yellow marbles, 7 green marbles. Okay. How many additional red marbles must be added to 18 marbles already in there, in the bag, so that the probability of randomly drawing a red marble is 3 out of 5? Okay. So you want the probability to be 3 out of 5. Okay. Now there are already 18 in there. Okay. And there's 6 red one there. Now if it's the way it stands, 6 red marbles over 18, the probability is 1 in 3. Because there's 6 red marbles out of 18 currently. So but you want to change that probability by adding more in there. So you're going to have to add something so it changes to this ratio. Well, you're going to have to add something there, so you have to add a certain number of them. But that will also increase the total number of marbles in there. So you're adding a certain number of red marbles, that's this. That will increase the total number by x. That will also increase the total number of red marbles. So you have to solve for x. Here, you solve this by cross multiplication. Cross multiply, butterfly method, double cross, whatever you like to call. You cross multiply here. So 5 times the quantity, 6 plus x, equals 3 times the quantity, 18 plus x. Okay, so 6 times 5 is 30 plus 5x equals 3 times 18, 60 minus, that's 54, I believe, plus 3x. Subtract 3x, get 2x from here, subtract this, you get 24. So x is going to equal to 12. Okay, if you didn't know that, you could just kind of like try it out, right? Let's say you didn't know that. You just try to start from the middle, okay? Okay, so you're going to add 18 more. Okay, let's go 6 plus 18 over 18 plus 18. Is that 3 to 5? That won't work, okay? Then you try this, and like they can just try them out. All right, the next question. This one says, which of the following trigonometric equations is valid for the side measurement x inches, diagonal measurement y inches, and the angle w in a rectangle? The fact that they told you that it's a rectangle is important, because if this was not a rectangle, you couldn't do this, because these are ratios based on right triangles. So you're talking about this over here. Okay, and opposite and hypotenuse. Well, you gotta know your trigonometric ratios. Okay, opposite of hypotenuse. This is so important. So katoa. So sine of w is opposite over the hypotenuse. It's that easy. It's just basically asking, do you know your SOHCAHTOA? Sine of w is x over y. Okay, so I believe the answer is over here. Now, we don't know this, so this is incorrect. Now, some of these are inverse. I see inverse sine, okay, that's the same thing as cosecant, but that's not mentioned here. Inverse of cosine, okay, is secant. 1 over tangent is cotangent. Okay, all right, so we got to talk about trigonometric ratios. This is kind of important. So trigonometric ratios, if you recall, they're derived from right triangles. Okay, if you don't have right triangles, you can't do this. So let's call this, we use theta a lot here, right? So like this. So the angle that's opposite depends, the side that's opposite is depending on what angle. If this is gamma, the side that's opposite for gamma is this. The side that's opposite from theta is that. Right? So the point of reference is important. The point of reference tells you which side is going to be opposite. I'm just going to make this up, 3, 4, 5, okay? So sine of theta is going to be the side that's opposite. So katoa. So sine of theta is opposite over hypotenuse, right? So that's opposite over hypotenuse, okay? And then cosine of theta is going to be adjacent over hypotenuse. That's over this. So that's 4 over 5. And then tangent of theta is opposite over adjacent. That's 3 over 4. Okay. And then if you wanted to do, okay, cosecant of theta, cosecant, remember if you flip the sign, in other words, you get cosecant, okay? And if you flip the cosine, okay, you get secant. Okay, they're complementary. Okay? So the cosecant of theta then, see, is just 5 over 3. Okay? And secant of theta is to flip this one and get 5 over 4. And cotangent is 4 over 3. Like that. They're just inverses of each other, flipping of each other. Okay? So you have to know these basic trigonometric functions. And then remember, simple rule. Okay, sine of gerene over cosine of gerene equals tangent of gerene. Sine of gerene or cosine of gerene is tangent. In other words, sine of theta over cosine of theta equals tangent of theta. If you take this divided by this, you get that. Okay, it's actually a very important property. No. Now, before I go on, let's say the question is, what's the measure of this angle? How much is theta worth anyway? What's the degree angle? Well, then you take inverse sine. See, so theta is inverse sine of 3 over 5. Okay. So you take inverse sine. When you do this, you have to make sure degrees versus radians. Your calculator has degrees and radians. So most of the time, you probably here dealing with degrees. So if you do it in degrees, so let's see if I could do this here. So function, I don't know if it's in arc sine. I don't know if I'm in degrees. We'll find out soon enough. 3 over 4. 3 divided by 4. I'm in radians, so I have to fix this, see? Oh, sorry, I didn't mean to do that. Excuse me. It's this. I changed it to degrees. Now let's see. I hope it stayed that way. 3 over 5, right? Is it fine? 36.9. So you have to be careful. So make sure that you're in the degrees and radians mode. So 36.9 degrees, like that. So this is very important. See, trigonometric functions is what allows us to find angles if we are given sides. Okay, it allows us to find angles if you're given sides. Okay, and if you're given angles, it allows us to find sides. That's how important they are. So the trigonometric functions are very, very important. So you got to know SOHCAHTOA. That's that. Question number 26. The slope of a line with an equation this, y equals ax plus b, is greater than the slope of a line with an equation this, y equals cx plus b. Which of the following statements must be true about the relationship between A and C? A and C, well, that's the slope of these lines, right? If slope of this line is bigger than slope of that line, basically the only way that's going to be is because A is greater than C. That's what it means. They're basically asking you here if you know this, y equals mx plus b. Do you know that when you give it in a line like this, that is the slope? So A has to be greater than C, like that. Okay. 27. Min cuts a board in the shape of a regular hexagon. She puts all this effort into making a regular hexagon, and pounds in a nail at each at an equal distance from the vertex, as shown in the figure. How many rubber bands will she need in order to stretch a different rubber band across every possible pair of nails? Why she's doing this, I don't know, but she's doing it. Okay, so how many rubber bands are we going to need? Well, let's just count. There's 1, there's 2, there's 3, there's 4, there's 5, and there's 6. Okay, that's 6 rubber bands, right? I'm going to erase those because we're going to need some room. Okay, all right, 6 rubber bands. So there's going to be 6 rubber bands that are going to go across. Okay, we're going to keep a tally, 6. Now, what you do with these questions, you see, these are popular. Then you just take one here. Start from any side, doesn't matter where. You already have a rubber band on the side, so there's no. Then you can go from here to here, okay? Then from here to here, and then from here to here. There's one already over here. That's plus 3, okay? You just have to do it carefully immediately. And then you go to the next one, see? Over here. Well, we already have one here. Okay, so go in the same clockwise, counterclockwise. Since I did clockwise before I did, let's do clockwise. I already have one here. There's one over here. I gotta put one over here. I gotta put one over here. That's 3. I already have one over here. Okay. And then let's go to this one now. Alright, go clockwise. I got one here already. Okay, I got one over here. I gotta put one over here. This one is already there, see? Plus 2. And then finally, okay, we did that one. Now we go from here. Okay, we're going, okay, got one over here already. I got put one over here. This one is already there. This one is already there. Okay, that's plus 1. And then you'll see everything's already done. All the rubber band spaces are taken. Okay, once you get to 1. So it's going to be the tally of all of this. 6, that's 9, 10, and 12, 13, 14, 15. It's going to need 15 rubber bands. Okay. There are 280 runners registered for a race, and the runners are divided into 4 age categories. That's a lot of runners. That's pretty good. As shown in the table below. Okay, under 16, 16, 25, 25, 35, over 35. And this is how many? Oh, it's a lot of 20. This is the biggest group is interesting like that. The prize committee has 60 prizes to award and wants the prizes to be awarded in proportion to the number of runners registered in category. How many prizes should be designated for this age group? Well, that age group had 112 runners. Out of how many? Let's see, 112 out of, let's have to figure out. So that's 112. 112 plus 40 plus 76 plus 76 plus 52. So that's total number is 280. Okay, that's how many. That's the proportion. And then you have 60 prizes, so you have to do this. Okay. So 112 over 280. So 112 divided by 280. Okay, and then times 60, 24. So you're going to have to give these folks 24 prizes. That's the biggest group. So that's this over here. Okay, 29. Alright, this question says, a youth center has installed a swimming pool on the ground. The pool is a right cylinder with a diameter of this much and height is 6 feet. Okay, okay, there's a ladder too. Alright. To the nearest cubic foot, what is the volume of water that will be in the pool when it is filled with the water to a depth of 5 feet. So you're not going to fill the tank all the way up to 6 feet, right? Whoever's fills the whole pool up all the way up there. So you only want to fill it up to 5 feet. See, like this over here. So that's going to be 5 feet. It's going to be 5 feet high water level. So what's the volume of water? Well, it's going to be a cylinder. Okay, volume of a cylinder is area of the base. Okay, base circle times the height. The area of the base circle is pi r squared times the height of the cylinder. Okay, in this case, the radius of this is 12, and the height is not 6 feet but 5 feet. Okay, so that's going to be 144 times pi times 5, okay? That comes out to be this, I believe, okay? That's how much volume of water is going to be in there. So just remember, the volume of a cylinder is the area of the base, which is this circle, okay, times the height of the cylinder h. That's the volume, okay? And number 30. A plastic cover is being made for the pool. The pool will rest, the cover will rest on the top of the pool and will include a wedge-shaped flap that forms a 45-degree angle here at the center of the cover, as shown in the figure. A zipper will go along the one side like this, with an arc. Which of the following is the closest to the length in feet of the zipper? So you want to know what this plus this is. All right, that's what you want to know. Well, this is easy now because that's the diameter of the cylinder, which is what? Not the diameter, I meant to say radius, which is 12. The radius is 12. Now we have to find this arc length, see? See, arc length. The arc length is some fraction of the circumference of the circle. Okay? So you take the circumference of the circle and you take the fraction. What fraction? It's going to be the fraction of the arc. Okay? So it's going to be 45 over 360. That's the fraction that's going to be. Of the circumference, which is 2 times pi times the radius, is 12. Okay? So this is 1/8 times 2 times pi times 12. 2 goes into 1 times, it goes into 4 times, 4 goes into 1 times, and 3 times. That's 3 pi. That's 3 pi. This is the arc length, okay? And then you have to add that to 12 pi. Okay, so this is 3.14. It's 9 plus 12 is at 21, 22. That's this. Okay. All right, so I got to review a couple of things for you here. Now look, when you have a circle like this, okay, and you cut out an arc, the arc length is this, right? Remember that? If you want to find the arc length, okay, if I give you a circle over here and I tell you I'm cutting into 4 equal pieces here, okay, and this is 90 degrees, right? And the radius is 5, right? So the circumference of the circle is 2 times pi times r, which is, in this case, 10 pi. That's the circumference. Well, this arc length, would you say, is going to be 1/4 of the whole thing, right? Correct? 1/4 of that. So it's going to be 1/4 of 10 pi. Correct? That's how you find arc length. So in summary, see, you can find the arc length because every arc length is going to be some fraction of the circumference. So the arc length is a fraction, okay, of the whole circumference of the circle. Okay? What fraction? Well, if you know the angle, okay, in this case it was 45, it's going to be 45 over the whole thing. Okay? Or it's going to be so it's going to be the fraction of the, if you know this angle, it's going to be that angle over 360. So it's going to be this fraction of the whole circumference. This is how you calculate arc length. Okay? Now, same thing. This, if this was like, you know, a slice of pizza, the area of this is called a sector. Okay? That's the arc, and this is the sector. The area of a sector is going to be the same thing. It's going to be a fraction of the area of the circle. What fraction? The same fraction, okay, like that. So area of the sector is a fraction of the circle, and the arc length is also a fraction of the total circumference, okay. So that's what this question is testing. It's also testing, you know, whether or not the volume of a cylinder is area of the base circle times the height. Okay. As a reminder, the surface area of a cylinder is a different story, right? The surface area of the cylinder is going to be the area of the bases. There are 2 of them, 2 times the area of the circle. This is the surface area, total surface area. plus the lateral area. That's like, the side. And if you recall, the lateral area opens up into a rectangle. Okay, this is the height. And the length of this rectangle is going to be the circumference of the circle. This circle. So the total surface area is going to be 2 times the area of the base plus the lateral area. So it's going to be 2 times the circles, okay, plus the lateral area, which is the rectangle that opens up when you open this up. So that's going to be 2 times pi circumference of this times the height. Okay, so this is the total surface area of a cylinder. Okay, inshallah, we'll have an opportunity to talk more about solid figures and geometry, so we'll talk more about that next time. We're going to take another pause, and then after that we'll continue with the next 10 questions, inshallah. Until then, salatu wassalamu ala rasulillah walhamdulillahi rabbil alameen. Assalamu alaikum.